Today we're making Flappy Bird, a relatively easy game to get your head around Unity and how to code certain simple things. And if you want the entire project with all the scripts already written to look around in and play around with, there's a link down below in the description to my Patreon where you'll find a link to download. First things first, we're going to import our sprite sheet. I'll link down below in the description to this sprite sheet. Didn't make this myself, just found it on Google, but it's a useful thing to have. But as you will see, this is just one image and we can't use the individual sprites. So what we're going to do is we're going to click the image file in Unity. And then over here in sprite mode, we're going to set it from single to multiple. And then we can apply that and open up the sprite editor. Here we can choose slice and we can keep the type at automatic. This will automatically detect where sprites stop and start. For the most part, if you're downloading sprite sheets online, that works fine. So now that we apply that over here in the top right corner, all of those separate sprites are now available to us. Of course, we're making the Flappy Bird game. We're not going to bother with the animations for the time being. We're just going to make the functionality. So we'll take this middle sprite and drag it into our scene. And it's ridiculously small. So we're going to want to make it a little bit bigger. Over here in the scale section, we will first enable this little chain so that it doesn't have a cross through it anymore. And then we can set it to like 5 times scale, maybe even 6 times. Then we run into our first major issue. And that's, if we scale it up that much, it's going to be blurry as hell. And luckily there's a simple fix around that, because this is all pixel art. The scaling method that Unity uses by default is bilinear, which is very good for scaling textures and the like, because it doesn't pixelate, it blurs. But for pixel art, you're going to want to change the filtering mode to point or no filter. Once you apply that, you'll see you have your very sharp pixel art back. And then we can also add in the floor here. Let's make that 5 times bigger as well. But it's not wide enough, right? And if we just do this, it's going to stretch, and that we don't want either. So what we can do instead is here in the sprite renderer, we can say in the draw mode, instead of simple, we can set it to tiled. And now when we make it bigger, it will start tiling the texture, meaning that it's drawing multiples of this same texture based on the width or height for that matter. We could just do this. There's not a lot of use to it in this case, but that's how that works. We're going to make the floor a little bit longer on the right side than it needs to be. And we'll get to why we're doing that a little later on. Alright, so it's time to start working on the gameplay a little bit. How we're going to do this, instead of Flappy Bird moving through an endless generating world, which would be very, very difficult, we're going to keep the Flappy Bird character in place. He can only move up and down, and everything else is going to scroll by the character. That will still give us the illusion of moving forward, because everything is moving past us, but will be a lot easier to program, because we just need to spawn in everything here, make it go over the screen, and then delete itself here. So for our character here, we're only going to need to program it going up and down. Well, first things first, we're going to need to add some collision to this. So we can add a component, and we can say a capsule collider 2D. This will add a little green circle around it. If we zoom into that, pressing the Edit Collider button will let us edit the collider shape. But as you can see, we can only edit these 2 points. And that is because our direction is at the moment set to vertical. We're going to set that to horizontal because we want to actually squash this collider down a little bit so that it fits neatly around our sprite. I have some good news for you, and that is the moving downwards we're not going to have to program, because we can just add a rigid body 2D, and this just tells the engine, hey, this game object has physics, so calculate physics for it. And since physics also includes gravity, you can see where we're going. The object now has gravity, so will, if there's no other forces acting upon it, move downward. And if we also then add a collider to our floor here, which we can do with a box collider 2D, we can edit that one as well and make it as wide as the sprite. If we now play the game, there's not much of a game, but we'll see that the character falls down and it lands on the floor because it sees a collision happening here. From here, making the actual character controlling script is very easy. We're going to add a component again, and we're going to call this something like Flappy controller. We'll make the new script, so create and add. That then makes a new script file for us. And if we double click this script here, Visual Studio will open for us and we can start working on coding that little bit of behavior. So in order to move upwards, we're going to have to apply a force to that rigid body, a force opposite of gravity. So we're going to need a reference to that rigid body. In order to do that, we can make a rigid body 2D variable in our script and just call it something like RB. And then to give it a value in void start, we'll say RB equals get component rigid body 2D. This simply looks within this same game object for a rigid body 2D component and then gives that as the value for this variable we made. So now that we have that, anywhere else in our script, we can reference back to that component. And we'll be doing that in the update function, because in the update function, we're going to check if input get button down, and then in these quotations, we'll type jump, and then we'll put a line of code within there. Just holding on here for a moment, you might be thinking, okay, get button down jump. The hell does that mean? How does Unity know what it should do with that? Because jump is not a key on your keyboard. Over in Unity, if you want to find where these buttons are kept, you can come over to Edit, Project Settings. I'm going to just put that up here real quick. And then in the Input Manager, under the axis, you see some axes like horizontal and vertical, but you also see jump here. And we have positive button is joystick 3. But jump also is referenced up here, so you can have multiple of these entries with different buttons, with different keys linked to them. So up here, we'll see that the positive button is space. So we're checking in update, which runs every frame, if the jump button was just pressed or not. If it was pressed, we're going to set the RB velocity to be equal to vector2 up multiplied by a variable. And that variable is going to be a serialized field, which literally just means that we can edit it from in the editor. So it'll give us a little input field within the editor that we can change this around with. And that's going to be a float jump power. So then we can multiply vector2 up by jump power. And believe it or not, that is it. That is the entirety of the character movement for Flappy Bird. So now that we're back in Unity, we can see this doesn't do anything yet, and that's because it's multiplying by jump power, which is 0. If we put that to 2, we can see it works. Now, the jump power definitely needs to be a fair bit higher. That might be a little too high, honestly. But this is just something that you'll have to experiment with. I think 6 is what I used in my own Flappy Bird clone. That works decently well. Now that we can move, we need to make sure that the Flappy Bird character actually doesn't move left or right and only up or down. And that we can do within this rigid body, because we have this little tab here, constraints, which allows us to freeze rotation. That's definitely something that we're going to want to do. And also freeze its position. So we can freeze the position along the X or the Y axis. We're going to be freezing the X axis. In theory, this shouldn't matter, but it's just good practice to make sure that those are enabled if you're not going to be moving in those directions anyway. Now, before we get to the pipe spawns, we're going to make the floor here scroll by. And that is because it just gives a little bit more feeling that we're actually progressing through the level, right? So what we're going to do is we're going to, with this move tool, line up this pixel over here to be at the very end of the camera, because it's an easy reference point. Then we're going to come up here to Window, Animation, and Animation. And that will give you the animation timeline window. I'm just going to put it down here for now. With your object here selected, we can create a new animation. We'll just call it Floor Scroll. And now with that, we can add a property to our timeline to animate. So we can add property, and that'll be our transform position that we're going to be animating. And by default, it'll set you a keyframe at frame 0. That's entirely fine. We're going to be using that. Then we also got some keyframes at frame 60. We're going to be deleting those. And then we'll move our flooring a little bit to the left to a point where the bottom left pixel lines up again. This way it'll be able to loop. And we simply press this little button over here to add a key. And now between these 2 points on the timeline, it'll interpolate everything as the animation. To make it loop smoothly, we're going to select this first keyframe, right click, both tangents, linear, and we're going to do that with this other keyframe too. And now when we play the game, you can already it feels like we are the ones moving to the right, instead of this being the thing that moves to the left. Once we add in the pipes, that'll be even more so. Oh, and if you like, you can obviously also add in a background, which you can, if you want to, animate in a similar way, but you'll have to keep in mind that if you're doing that, you do want to have it animate at a very much slower speed because of parallaxing, but that's a little beyond what we're doing here right now, today. You'll notice that putting these sprites on top of each other is making a bit of a mess, so we can order in layer, which is just telling the engine this is supposed to be rendered on top of other sprites. So if we set this to -1, it'll be in the background. And don't forget to keep naming your layers as well, because otherwise it's going to be very confusing as to what sprite is actually doing what. Let's make the pipes. We can drag in these 2 sprites here and increase their size by a fair bit. Let's increase them by 3 times. And to make sure that they're exactly lined up where possible, we're going to be looking at the X position for the bottom sprites, and we're just going to copy over and paste it this way. They're exactly lined up. Both of these are going to get a box collider as well, because we want to have them be able to collide with the Flappy Bird. In this specific game, whenever we have a collision, we'll just reset the game because that is a game over. And we're not going to be building like a high score leaderboard or anything. And then we're going to put these 2 together under a parent object. So the way you do that is we're just going to add a empty, create empty. And we'll call that pipe prefab, because this is going to be a prefab in a second. Select the 2 pipe sprites and just drag them on top of the newly created empty. And now the parent is under that. So when we start moving the empty around, both of the pipes will follow. Now within the pipes, we want to set the position for X back to 0, so that they actually line up properly with where the pipe prefab empty object is. Because if we give this a visualization, you can see the object is actually right over here. So we can say the top pipe will be 3 units above it, and the bottom pipe will be 3 units below it. That's probably a little bit too small of a gap, so let's make that 8 is too much. It's a little bit of wiggling around as to what you think works. Maybe 3.5. For 3.5 for both seems a pretty good deal. That gives you a decent enough gap to squeeze through, I'd say. Before we get into counting score and stuff like that, we're going to actually make something that will spawn these pipes in for us. And we're going to make the pipes move across the screen. Let's do that first. So in the pipe prefab, the parent object, we're going to add a new component, and we're going to call that pipe mover, which will be our new script. Double click to open it up in Visual Studio. And here we simply do a couple of very easy things. And that is number 1, on the start function, we'll actually destroy the game object, but we can add a number after that as well. So if we say destroy game object 15, then once the game starts, it'll start a countdown of 15 seconds and then destroy the actual object. And just like with the Flappy Bird controller itself, we're going to add a serialized field here, which will be flowed for the speed of the movement. Then in void update, we simply say transform position plus equals, which means that we're adding something to the existing value, vector2.left multiplied by speed multiplied by time delta time. Actually, because we're using the transform position, which has a z value, even if we're not using it, we need to make this a vector 3.left times speed times time.delta time. So this is just to say, hey, you're going left. This is to say at which speed, and multiplying it by time delta time. To make a long story short, just make sure that you have consistent movement no matter your frame rate. And now, over in Unity, if we set the speed for the pipe to 1, we should see this pipe over here moving towards us very, very slowly. Then if we set this to like 3, we'll see that it's moving a fair bit quicker. With all of that done, we can get the pipe prefab, the parent object, and just drag it down into our assets folder, and that'll turn it into a prefab. So now we can delete it out of our scene, and we have the prefab, which is kind of like a preset of certain game objects grouped together that we can drag in if we want. Or rather, what we're going to do is we're going to be spawning them in. And we're going to be doing that through a empty object again. So we'll call this one pipe spawner, and we'll add a new script to that again, and we'll also call that pipe spawner, or just pipe spawn, I don't care. And in that pipe spawner, we're going to add a serialized field, and it's going to be type game object, which we'll just call pipes. We're also going to add a serialized field, a float, time between spawns. And then we're going to just add a normal float, and that will be called timer. We don't need the start function, so we can get rid of that, because everything we're going to do is going to happen within the update function. We're going to start with a if statement, and that is if timer is greater than or equal to time between spawns. We first set the timer back to 0, and then we instantiate pipes at transform position quaternion identity, which just says, hey, don't give it any special rotation or stuff like that, but you do need to specify its rotation value. And then after the if statement, we're going to put else timer plus equals time delta time. So this will do one thing every frame, and that is check if our timer is bigger than our time between spawns. If so, it resets the timer and spawns in a pipe. If not, it just increases the timer. Let's give this a visualization as well so that we can find where it is. And if we put this outside of the view of the camera, and we set the time between spawns to like 4 seconds, for instance, and we use the prefab we just made as the pipes game object that'll be spawning in, now we will start seeing that we every 4 seconds spawn in a pipe, a very slow moving pipe, which also after 15 seconds of existing should blip out of existence. But you'll be able to already see a major issue going on here, and that is there's no variability in their height whatsoever, which makes for a very, very boring Flappy Bird game. First and foremost though, let's set the speed to like 3, just to have them move a little bit quicker. So instead of just making a instantiate which just spawns in the object at the exact transform position, we're going to make a custom vector 3 for this. So we'll call this vector 3 spawn location equals new vector 3, and we have to give it a X, Y, and Z position. We're going to go from easy to difficult. So the Z value is going to be a transform position Z. And I've got good news for you, because X is going to be transform position X. The only thing that we're going to do weird stuff with is Y. And for that we're going to make a float variable, and we'll just call that Y offset, which will be equal to random range. And now we need to give it 2 values to pick a random number between. So let's just do -1, +1. And then with that Y offset, we can just get a transform position dot Y, and to that we'll add that Y offset value. And now when you play the game, you'll be able to see that there is variability in the height of where the pipe spawns. So this one is a little higher up, that one is a little lower down, and you can make this value bigger if you want. This is very easy because everything is very close together. So if you wanted to, you could make a serialized field, use those a lot, And we can just make that a float and call it spawn range. And instead of -1 to +1, we'd go negative spawn range to spawn range. And we can set that to 2 for a bigger contrast between where they can spawn. Do be careful of making this too big though, because it can get too big very, very easily. And that is the basic idea around Flappy Bird. We're going to make a death system and a score system. Again, we're not going to be making a scoreboard system here, but having a score up at the top of the screen is probably fun. So let's make the death system first, because that is very, very easy. Back in our Flappy Bird controller script, we're going to open that up and we're going to just minimize the start and update functions, and we're going to add a new function, which is on collision enter 2D. In this case, we don't have to specify any special things. Don't check for certain things to be true or not, because any collision happening in this game is either on a pipe or on the floor, which both means we die. So up top here, where it says using systems collections and all the way to Unity engine, we're going to add a new using, and that's going to be the Unity engine scene management. And in this new function, we're going to add a scene manager .load scene. And we can see here it needs a string for the scene name. You could just put the scene name in here. That is the easiest thing to do. So going back into Unity, we see this is called sample scene. Just put that in there and it'll load that scene. But if you then change the scene name for any reason and you forgot that this code exists, you're going to be very confused. So what we're going to do instead is we're going to put in scene manager get active scene dot name. This way we'll say load this scene through using the name of this scene, which will always just reload the current scene. Generally a useful line of code to remember in a lot of situations. So now if we fly into the ground, you can see the scene resets, and if we fly into a pipe, the scene also resets. That only leaves our scoring system, and luckily this is really, really easy. So for that, we're going to add a UI. Text Mesh Pro will be prompted with the TMP importer. We're going to import the essentials, and it'll also add a canvas for us. This canvas is our reference for the UI elements, and as you can see, it's much bigger than our actual scene view. It's kind of annoying, but that's just how it works. I don't know what to tell you. This is the text that we're going to be using to display our score. If you're familiar with anything like Photoshop, this will all be very familiar. We're going to set the spacing to being outlined through the center. The font size is going to go up a fair bit, and we're going to center this as best we can. And then we'll align this to the top, so that if there's any weird stuff with the aspect ratio and stuff, this text will stick to the middle center of your screen. Before we jump into the actual text display, we're also going to add a public integer for our score. This is the first time we're using a public variable, and that is because this is a variable that's going to have to be read by another class. Because we're going to add a script to our text. You might be thinking, the text can't be all that complicated. What the hell are we going to need a script for that? And that is going to be the score display. And you would be right, this is actually not that complicated. We're going to start off by adding a using for TM Pro, and then we're going to add a text mesh pro UGUI variable, which we'll just call TMP. TMP will get a text mesh pro GUI get component value at begin play, and then TMP.text is going to be equal to our score variable that we've just added to our Flappy controller script. So for that, we're also going to add a Flappy controller variable and just call it player. This one will be a serialized field. And now we can just say player score to string. This will get the score variable from the player that we provide to this text and make a string out of it so that we can display it as text. And luckily Unity is intelligent enough to the point where if we just drag a game object that has the right components on it into this field, it'll automatically get the right script to reference here. And as you can see, we have a score counter saying 0. but we are not getting any score yet, and that's because we haven't programmed that in. Nothing happens unless we tell the game something needs to happen, right? So I'm actually going to go back into the pipe prefab real quick, because we need to add one more component here. And that is going to be another box collider 2D. We'll edit this collider to be big enough to cover the entire thing between the two pipes, because we're going to set this to is trigger. Any collider can also be a trigger collider, which means that it won't be taken into account for collisions, so you can just move right through it, but it will be able to be used for things like trigger events. So that's exactly what we're using this for. Then in our Flappy controller script, we can simply just add a on trigger to the enter, and we'll just add a score ++, which will add 1 to the score. And with that, we have finished our Flappy Bird remake. As you can see, I am not very good at playing Flappy Bird, so it's not going to get a very high score here in the demonstration. But if nothing else, you can definitely see that the death mechanic is working, because I am showing that off a lot. And now that we've got a couple of points in here for score, you can see everything works like a charm. If there's any other games that you think, hey, maybe you can make a video on how to make something like that, I would very much like you to leave a comment down below. If there's anything specifically about this tutorial that was unclear, again, please do leave it down below and I'll try my best to help you out, or maybe make a dedicated video to a specific portion that might have been unclear. And for that, you know what I'm going to say, because you've been on YouTube for a while now probably, it'd be nice if you subscribed. Subscribing really does help the channel grow a lot, so if this was helpful or enjoyable, please do subscribe, and I will see you back in the next video.